Welcome to TOC class. Here in this session we discuss the problems in finite automata. First, we already know that the difference between a deterministic finite automata and non-deterministic finite automata. So the easy way of construction of finite automata is only NFA, but we are in need of implementing DFA in a systematic manner. So there is a need of conversion of NFA to DFA. And if there is any NFA which contains epsilon in it, then that NFA is called as epsilon NFA. So these are all the three problems. Problem number one is NFA to DFA conversion. Second problem is conversion of epsilon NFA to NFA and conversion of epsilon NFA to DFA. So I give the step-by-step procedure for implementation of these three problems. Then at last we just check same problem, that is a conversion of epsilon NFA to DFA states are equivalent to conversion of epsilon NFA to NFA and NFA to DFA. So if you go for the resultant DFA states, that should be in a minimized DFA form. So this minimized DFA will be discussed at the end of unit 1. So now I give the introduction about the NFA to DFA conversion. So which means that it is also named as equivalence of NFA with DFA. So this is the generalized form. Every DFA is an NFA which is known that the class of languages accepted by NFA includes regular formations, which means that if you construct an NFA which can automatically simulate a DFA. So what is the theorem says means, let L be a set of states which is accepted by NFA, then there exists a DFA which will also accept the language L. So the name for conversion of NFA to DFA is called a subset construction method. So this is the notation. So either they can, in an university exam they will ask the equivalence of NFA to DFA theorem. Otherwise they will give like this. That is, a language L is recognized by DFA if and only if there is an NFA N such that L of N. This is the NFA language. This is the DFA language. So it may be equal. Then what is the procedure for implementation? So it contains 5 steps. In first step, the step 1 is subset of NFA calculation. That is, what are the possible subsets are available in NFA. We should calculate in step 1. So it is a given statement. So they will give NFA. So let NFA N contains quintuple representation 5 states where Qn contains Q1, Q2 like this. So it is represented within a set. And we should need to calculate DFA. So the DFA state should be mentioned within square bracket. So if any states which is available within a set means it is an NFA state. If any state which is written within square bracket means which means that those states are DFA states. So how can we calculate it? So this is the given number of states NFA. So Qn means if Qn contains, that is a Qn means NFA set of states. So 2 power Qn possible values are available in QD. QD means DFA states. For example, if an NFA contains 3 states, the possible set of states in NFA is 2 power 3. 2 power 3 means 8 possible values are possible. So how can we know about it? For example, NFA contains Q0, Q1 and Q2. So let Qn is equal to these values. So what are the possible QD state means it is also a set of states. Each state should be mentioned within square bracket. So null set may be available. Otherwise, within a square bracket, if you mention only one state means there may be the possibility of only Q0 or Q1 or Q2. If the square bracket contains 2 state means you can able to write it as Q0 Q1, Q0 Q2, Q1 Q2. If the square bracket contains 3 states means you should write all the states within square bracket. So you count all these states 1, 2, 3, 4, 5, 6, 7, 8. So 2 power 3, these are all possible set of states. So it's not necessary to retrieve all these states from the given NFA. There may be the possibility of few states which will be retrieved from the given NFA. So this is the sample calculation. So here QD denotes the square bracket of states where a set of states will be discussed as Qn. So this is the step 1. In step 2, what are all the starting state of NFA that will also be considered as DFA states? For example, Q0 is an NFA starting state. So tilde of Q0A contains two values Q0, Q1 and Q0B contains Q1. So this is the starting state of NFA which is implemented within two input symbols AB. Then how can you write the starting state of DFA? Means the starting state of DFA is also Q0. So tilde D, this is the DFA transition flow. Q0A is equal to, you write the set of values within square bracket. So within square bracket means Q0, Q1. And then tilde D of Q0B, which is equal to, it contains only one state, so you write it within single state. So you check these values, square bracket of Q1, it's also predicted, Q0, Q1, which is also predicted. So these are all DFA starting states. So wherever starting states of NFA is available, those states will be also be considered as a starting state of DFA, but that should be mentioned within square bracket. And then step 3 is a repeated process. So this is the resultant answer. So I write it as a DFA transition table form, which contains input symbols AB, and my starting state of DFA is Q0. So this is the DFA starting state. So I should write within square bracket. And the answer is also available. Tilde D of Q0A is what? Q0, Q1. So the answer should be written within square bracket Q0, Q1. Then what is the answer of tilde D of Q0B? It is Q1. So you write here. And these are all the new DFA states. So we should calculate the DFA transition function for these new states. So you write these new states beneath this first state. Then you check the answer from the given NFA. So this will be this is a repeated process. So tilde D is computed by applying the transition flow of NFA to each state of Q tilde D. So this is the main reason for implementation. In step 4, this will be considered, it is a repeated process. So if any iteration steps are available, those iteration steps can be implemented with the help of induction proof. We already know the induction proof technique. And after completion of all the calculations, we should know, or we should find out the final state of DFA. So how can we find it out? What are all the NFA states, NFA final states are there? Those NFA final states will also be included as a DFA final states, which means that there is no empty final states in DFA. Then let us discuss the problems in next session. Thank you.